Okay, today we're working on writing equations of line. This should be all reviewed, but I know it's been a while, so we're going to jump right in. Remember the types of lines that we have. Hope you can see that. If not, your notes will show it clear. Secant line touches twice. Okay? It can't cross or touch. It doesn't matter. So if you have a secant line, that means you have a curve. Okay? And you have 2 points that it goes through. Pretend that's a line. That's a secant line. Now, it might hit a third time down the road. It doesn't matter. But it's saying if you have 2 points, the line that connects them through a curve is a secant line. Now, I always remember that as secant and second. It's going to hit twice. The other type of line with a curve is if you have a curve and it only touches, kind of like grazes, once. Okay? Now, it's not going to go through. That's not a tangent line. Oh, dang it. But if you have one spot and like the line kind of grazes that one spot, this is tangent to the curve. Okay? It's going to touch once. And this is unique. There's only one tangent line. And this is a very, very big concept of calculus. Okay? Very big concept. Tangent lines. So that's why we're covering this section, is to get used to tangent lines and writing equations. But know the difference between a secant line touches a curve twice. A tangent line kind of grazes a curve. Okay? It does not go straight through it, though. Okay? It's kind of grazes it on the outside. So we're going to start off. I hope you can see that. I can change the color real quick. We're going to find a value of x so that the slope of the line is -3. Okay, and of course, remember slope is change in y over change in x. So we're going to go ahead and set that up. Remember, y is going on top. So I have 7 minus -2 for my y's, x minus 4. Now remember, it doesn't matter what order you go in as long as you're consistent. So if I start with 7 minus -2, I have to go in the same order. I could have done -2 minus 7, 4 minus x. Okay? So when I clean this up, plus plus, I get 9 over x minus 4, and I want to know when that equals -3. That's my slope. When does it equal -3? Well, to solve that, I simply cross multiply. So I have 9 equals, make sure you distribute that -3, -3x plus 12. Subtract 12 from both sides, I'm going to get -3. So x is 1. And of course I can check that by finding the slope if that was 1. 7 minus -2, 1 minus 4 will give me 9 over -3, which is -3. It's very simple. You've done these when you were little. Just remember, y's go on top. We're way too big to be making the mistake of putting x's on top. Okay. Now this is the form you're most familiar with, and every time I ask what is a line, everyone gives me this. And that's slope-intercept form. Y equals mx plus b. Remember, m is the slope, b is the y-intercept. This we know pretty well. We actually just did this with piecewise. So some quick graph review. If I want to graph these lines, my slope here is -2. My y-intercept is 7. So start at 7 on the y-axis. And I'm going to move, remember this fraction, top number tells you up or down, down 2 over 1. Down 2 over 1. And then connect them. And make sure your lines have arrows. Mine do. I know it might be hard to see on that camera because they go on forever and ever. Now over here, we might have to get y by itself. Well, plus negative, because we're not going to make that freshman mistake. And hold on, if my board will cooperate here. So plus negative. So you could arrow diagram, or we can solve it the old-fashioned way. So I'll have -4y equals 8 minus 2x when I take that over. Divide by -4. So I'll have 2, oops, that's a -4, -2 plus 1/2 x, because 2 over 4 reduces. So you see my y-intercept is -2. I'm going to move up 1 over 2. Up 1 over 2. Voila. And please grab a ruler. I have rulers in my classroom if you need them. Okay, now this is the big one that we use the most in calculus because it's usually the easiest to start. It's point-slope form, and for this you obviously need a point and a slope. So in this case, these are my variables, x and y. Those don't change. They are x and y. This is a point, x1, y1. I think maybe Mrs. Bybee covered point-slope with you. I'm not sure if you're one of the groups she did. She does sometimes in the advanced classes. So we have a point, x1, y1, and then of course we have our slope. Okay? So m is the slope, x1, y1 is the point. So you're actually going to fill in numbers for those, and then we clean it up. Why we use this over the other, you don't have to, but I want you to know the point-slope form and how to do it because, like I said, this is what we really stick with the most in calculus because it's usually easier calculation-wise and what they kind of look for in the AP test anyway. So that might be a little bright. Let me change that. Okay, maybe not. There we go. Okay, so find an equation of a line that has slope -1/2. So right away, m is -1/2. Goes through the point 3, -6. Now we're going to use our point-slope form, which is y minus y1, mx minus x1. So this is your x1, y1. That, of course, is your m. So I have y minus -6, so it's going to be plus. My slope is -1/2, x minus 3. Now all I do is clean up. I'm going to distribute, and we don't need calculators. You shouldn't be using a calculator for this. So I have -1/2 x plus 3/2. 3 times -1/2. So we positive. Okay. Now subtract 6 from both sides. Once again, we don't need calculators. 3/2 minus 6. Common denominator. Use a 2. So I really have 3 minus 12, which is -9. So -1/2 x minus 9/2. There we go. And yes, I do want you to use point-slope form. Okay? I want you to get in the habit of using point-slope form. Okay, so all we do is distribute and then add off, just to clean up. Get y by itself. So it ends up being slope-intercept form, but we start with point-slope. Now this is a good question. I gave you a few of these on your practice handout. I want an equation that is secant to the curve. So here's what's going on here. I know I have x squared, and I have at -1 and at 4. I want that line that's secant to the curve. Okay? We really don't have 2 points, but we can find them. At -1, if I plug in -1 here, I'm going to get +1 for my y. So now I have a point when I plug it in. I get my y. So same over here, when I plug that in, 4 squared, I get my y to be 16. So now I have 2 points. So that's all you have to do in this problem is first find your y's, and then it becomes a normal problem. So from here I can find my slope. So m is 16 minus 1, my y minus y, x minus x. 4 minus -1, which is really plus. So I have 15 over 5, which is 3. Now, pick a point. I'm going to use the smaller one. We're going to do point-slope form with my m and my point. So y minus your y, in this case, which is, well, I'll go ahead and write down the formula because I'm a good little mathematician. X minus x1. So I have y minus my y, which is 1. M is 3. X minus negative really makes it positive because the formula is minus. Distribute. I have y minus 1 equals 3x plus 3. Add off. So I really have y equals 3x plus 4. There's the equation of this secant line. So I threw a couple of those in your review handout. Know how to find a secant line. The trick is just finding your y first. Okay, let's do another. So I have it 2x cubed, which the next section you're going to learn looks like that. I'm going from -2 to 2, so I want a line that kind of looks like that, just to give you an idea of graphically what's going on. But if I plug in -2, I'm going to have 2 -2 cubed. That'll give me -8 times 2, -16. Plug in 2, very similar. It's going to give me positive 16. So now that I have 2 points, let's find my slope. 16 minus negative 16, 2 minus negative 2. So here I'm going to get 32 over 4, which will then give me 8. So I'm going to use my slope, and let's use the positive point. Y minus y1, mx minus x1. Y minus 16 equals 8, x minus 2. Okay, distribute. I have y minus 16 equals 8x minus 16. So add 16 to both sides. Okay, y equals 8x. Voila. Okay, now to remind you, parallel, perpendicular, because it may have been a while, parallel lines have the same slope, right? Because if you want a line that's parallel, their slopes better be the same or they're going to cross. Okay? Perpendicular lines have opposite reciprocals. Okay, meaning opposite, they have different signs, so one's positive, one's negative. Reciprocals means you flip it. It has to be both. Okay? So graphically, you have a line, you want a perpendicular one. That's why they have to be opposite, because they have to be going different ways. The slopes are reciprocals. Okay? So what we're going to start off with is I want an equation for a parallel line, perpendicular line, to this line that passes through the point. So graphically, here's what's going on. I have a line like that. I want a separate line that's parallel and goes through this other point, this 8, negative 1. So I'm given a line, I'm given a point. I want another line that goes through that point that's parallel to that. So that's what I'm asking for in point A. So first things first, I need the slope of this line. Well, this line has a slope of 1/4. So if my line is parallel, it's going to have the exact same slope. And now I have a point. So let's go ahead and use our point slope form. And let's go ahead and put it in standard form. I don't think those are in the notes. I want to make sure you remember standard form. Y minus negative 1, 1/4 x minus 8. Distribute 1/4 x minus 2. Now, I'm going to go ahead and work on putting it in standard form. I can add up, or I can do it later. We can do it now because it's no problem. Minus 1. So y equals 1/4 x minus 3. Now, to put something in standard form, first off, no fractions. So I need to multiply everything in this case by my denominator, which is 4. So I'll get 4y. Here, when they'll cancel, I'll get x minus 12. Now, last but not least, to put it in standard form, x's and y's must be on the same side, but coefficient to x must be positive. So you can't just take x over because that would make it negative x. So what you really need to do is take this over and then take your 12 over. Okay, so I'll really have x minus 4y. When I take that over, take the 12 over, I have 12. And I don't really like it written like that. You'll always see it written like this. So for a line to be in standard form, no fractions, so get rid of those. And then also, x coefficient must be positive. Okay, so when you get x's and y's on one side, they must be positive. Okay, so we're halfway done with that problem. That's parallel, now I want perpendicular. So if this line has a slope of 1/4, a perpendicular line is opposite, so it'll be negative. Reciprocals, 4. Still the same point. So y minus y1, mx minus x1. So I have y minus negative 1, negative 4x minus 8. Distribute y plus 1, negative 4x plus 32. Let's subtract 1 from both sides. So I have y equals negative 4x plus 31. Now let's work on putting it in standard form, just for practice. There are no fractions, so I don't need to worry about that. I do need to make x be positive and on the same side as y. So let's take it over. I just have 4x plus y equals 31. So standard form, no fractions, and when x's and y's are on the same side, x must be positive coefficient. I think we we have one more and we're done. It's the same thing. I want parallel perpendicular lines to this other line, passes through this point. But this is a little different because this is not in point slope form. And do not make the freshman mistake going, oh, slope is 5 because that's in front of the x. No, it's not. We're going to have to put it in slope intercept form to find the slope. So if I have 5x plus 2y equals 8, subtract 5x, divide by 2, I have y equals 4 minus 5 halves x. So the slope of this line is negative 5 halves. Okay, you can't see that right off the bat, you have to do a little work. So now for part A, I want a parallel line to this. So the slope is going to be the same. I'm going through the point negative 2, 4. Once again, we're going to put it in standard form to get practice. So I have y minus my y, slope, negative 5 halves, x minus negative 2. Let's distribute. Negative 5 halves x, that would be minus 5, because 2's will cancel. Okay, let's go ahead and add 4. Negative 5 halves x, when I add 4 I get minus 1. Let's put it in standard form, so let's get rid of that fraction. Here's my denominator is 2, so I'm going to multiply everything by 2. I get 2y, it's negative 5x minus 2. Now I need x's and y's on one side, but x must be positive, so let's take this over. So I have 5x plus 2y equals negative 2. Voila. Let's work on part B. Perpendicular. So if your slope is negative 5 halves, the slope of a perpendicular line is positive 2/5. Opposite reciprocal. Still going through the same point. So y minus 4 equals 2/5 x minus negative 2. Distribute. Y minus 4 equals 2/5 x plus 4/5, because that's 2 over 1. Now instead of adding opposite and doing some common denominator, I'm going to go ahead and eliminate my fraction now, just so I can avoid a little bit of fraction work. Okay, your common denominator here is 5, so I'm going to multiply everything by 5. So I have 5y minus 20 equals 2x plus 4, because they will cancel with these two terms. Now I'm going to add opposite. Well, actually, let's wait. Let's take this 5y over, because you know this has to stay positive. So I have 2x minus 5y. Same time, I'm going to subtract 4 from both sides. Okay, so I have negative 24. And I don't really like it written that way. We're going to write it as 2x minus 5y equals negative 24. That's perfect standard form. No fractions, x coefficients positive. So homework is your handout. It should be on progress book. If you need extras, I have them. Actually, I have them in class. I'm going to give them to you, but it's also on progress book if you lose it. If you have questions, make sure you come in and ask anytime. I will also make the key for your homework available, so you can just come on in and check your answers anytime you want. Okay? So make sure you ask questions if you have any.